Welcome to Dev Tested, Ops Approved, 10 Atlassian Guardrails for better, faster DevOps. My name is Jake Brereton, this is Stephen Henderson, and on behalf of both of us, I'd like to simply start by welcoming you all and saying thanks for being here with us today. We're thrilled to be here to speak with you. Over the years, Atlassian has developed a set of proven, dependable DevOps practices that have allowed us to increase velocity and ship more reliably. We're thrilled to be here today to share 10 of these time-tested techniques with all of you. But before we get into the specifics of our DevOps practices, let's start by taking a step back and just talking about why Atlassian embarked on this journey to begin with. What was the forcing function to create the guardrails that we swear by today? Like many of you in your teams, for many years, Atlassian has been grappling with complex distributed teams, ever-increasing demand on our products and services, and a greater need than ever for fast, stable release cadence and reliable uptime. To thrive, we had to deliver day in and day out. Again, this is something most of you, I'm sure, are very familiar with. We also knew, like the Navy SEALs like to say, the only easy day is yesterday. If we were facing any problem, it was only going to get worse with time and scale. So the first major shift that we made to help us deal with these challenges was to adopt Agile software development practices. It should be no surprise that over the past decade, Agile has quickly become the standard across the entire industry. According to a 2016 State of Software report by Atlassian, where we surveyed 17,000 software professionals, including 1,300 of our own users, 77% of teams reported using Agile methodologies. However, it wasn't long before we realized that Agile software development doesn't necessarily mean Agile software deployment. While dev teams were shipping software faster and faster, ops teams were still on the hook for scalable systems, reliable systems, and stable systems. And these increasingly rapid changes from dev kind of run counter to that. And so the chasm between dev and ops began to widen, and an ops gap formed. Enter DevOps. For the past 15 years, Atlassian has been working in partnership with thousands of our customers and partners to close this ops gap. Over the past decade, of all the different tools and practices that we found helpful in our own journey, we've identified two key pillars that we believe are essential to achieving DevOps success. The first is building a true culture of collaboration. And the second is maintaining a reliable release pipeline. Now, both of these are crucial to ensuring a smooth flow of software from our hands into yours, and they'll be woven in throughout today's presentation. Now, thankfully for all of us, especially everyone in this room, we're not the only ones seeing success with DevOps. So in case there's any doubt that it isn't making a difference, here's some stats that show that teams that have adopted DevOps and are seeing success with it are killing it. Just think where you and your company would be if you could deliver what your customers wanted 430 times faster. Or if you could recover from failure 96 times faster. It doesn't matter if you're on the dev team or an ops team, the ROI of this is incredible. It's worth the investment of your entire organization. Now, before we dive into Atlassian's 10 guardrails for better, faster DevOps, I also want to quickly explore the three themes that underpin these practices that we swear by. Our 10 guardrails fall into what's commonly known as the 3 ways of DevOps. If you're not familiar with the 3 ways, they were introduced by the authors of the Phoenix Project. They are systems thinking, improved feedback, and constant experimentation. But at Atlassian, no matter what the topic may be, we love to put our own spin on things. Renaming everything, it just seems to be a part of our culture. I think it has to do with our Australian heritage. So internally, we found that a more valuable way to think about the 3 ways of DevOps are knowing the flow, controlling the flow, and improving the flow. First, learn to see and truly understand the flow of work that gets created and delivered. Second, learn how to plan and schedule new work through that flow in a healthy, realistic way. And finally, as a team, take intentional steps to improve the flow of work over time. And it's through this lens, knowing the flow, controlling the flow, and improving the flow, that we'll be taking you through Atlassian's 10 guardrails of DevOps. So let's get started with how we capture and define our flow of work. Now, at Atlassian, it should be no surprise that we use our products to build our products. The way we see it, the faster we can get our products into our own hands, the faster we can iterate on them and get them into the hands of our customers. So our first guardrail, it's all about flow, is about how we're laser focused on cycle time. Atlassian defines cycle time as the amount of time it takes to get a feature from concept to code complete and into the hands of customers. Because cycle time can vary greatly based on the engineer, the team, the problem being solved, what they're building, it's very hard to optimize with tools alone. And so we lean on DevOps and its practices to manage the flow of work, minimize cycle time, and ship new features as fast as possible. And the 3 ways of DevOps provide the perfect structure for our teams to do this. The first way, systems thinking, it teaches us to seek honest visibility into our process. It encourages automation to track the process and process tasks and report status changes. And it ensures that we're always putting a premium on building systems that accurately monitor the cycle time of our work, which is so crucially important. It's also important to ensure that everything the team is working on is visible and understood by the entire organization. Hidden work is the root of all evil when it comes to knowing the flow. The second way, improve feedback. It serves as a reminder to continually prioritize the most valuable work. It requires making realistic commitments to the team and organization and aligning pace with velocity. When the flow of work is deterministic and visible, the team is empowered to manage surprises without confusion, and this minimizes bottlenecks. And finally, the third way, constant experimentation. It encourages us to continuously test new ways of innovating and optimizing our flow. Atlassian teams go out of their way to suggest and experiment on new ways to increase efficiency across every phase of the development lifecycle. Now, this mindset of constant experimentation, it's particularly valuable because it puts a premium on preventing future bottlenecks. It's always forward-looking. And these bottlenecks may exist anywhere in the development process, but they must be rooted out. Now, speaking of end-to-end development process, as I mentioned earlier, we rely heavily on our own tools to know, control, and improve the flow. And this brings us to our second guardrail, eat your own dog food. Whether it's planning, building, deploying, or any step in between, we use our tools at every stage. Dogfooding not only builds empathy between ourselves and our customers, but it gives us full visibility into every phase of the development and our flow of work. But I know what you're thinking, enough generalities. So let me give you 2 specific examples of how we dogfood our tools internally. Across the software development industry, Jira is pretty much ubiquitous for project and issue tracking. So it should be no surprise that this is the same within the walls of Atlassian. For example, to date, Atlassian has over 20 active instances of Jira that we use for literally everything. From software development to finance, strategy to IT, Jira Software, Jira Service Desk, and Jira Core, they provide a common language across our entire organization. One such example is the aptly named JDog, which is the Jira Software dogfooding instance. It's used by the majority of the Jira team to build Jira. As of 3 weeks ago, JDog is home to 337 projects, 468 custom workflows, 918 boards, and over 836,000 Jira tickets. To put this number in perspective, if you were to file 100 tickets a day, it would take you 23 years to fill a Jira instance to this size. And keep in mind, JDog, it's only one of 20 instances that we use. So when I say our internal teams rely heavily on Jira to plan, track, and ship software, and that we swear by the 10 DevOps guardrails that we're talking about today, these aren't just convenient talking points. Atlassians heavily dogfood our own products, and we live in Jira. But it's not just everyday work that we use Atlassian tools for. We also rely on our own products when the pressure's on and we're dealing with bugs, downtime, and other issues that directly impact our customers. As all of you in this room know, this is when it really counts. This is when our dev and ops teams really get to push our products to the limit. Let me show you. In a crisis situation, the basis of our response system consists of multiple integrated Atlassian tools. The SRE team uses Jira Software to track a hot issue through to resolution. They use Confluence to capture all necessary context throughout the incident a combination of HipChat and BlueJeans for real-time face-to-face communication, and status page to keep all external stakeholders and users in the know. Now let's take a look at exactly what happens when an incident strikes. Whenever a hot ticket is created in OpsJ, which is one of the Jira software instances used by our operations teams, a microservice called IMA jumps into action. IMA creates a Confluence page, a HipChat room, and a secure private BlueJeans bridge. Then it automatically connects all of these assets together and prints URLs for each of them into custom fields on the hot ticket in Jira. Once this process is complete, the hot ticket becomes the team's single source of truth throughout the entire incident. All work flows through this single ticket. By tying all necessary comms channels together, there's never any confusion on what the most up-to-date status is, what decision needs to be made, where the video conference is being held, and so on. But IMA doesn't stop there. Once every communication channel is linked to the Jira ticket, it begins scanning support.atlassian.com to determine how many other related support requests are flowing in. It then displays this count directly on the Jira ticket itself. And as the support tickets continue to roll in, it updates in real time. Talk about peer pressure. At the same time, IMA also surfaces as much information as it knows about the incident in a custom area on the ticket called dates. Dates provides all stakeholders with important dates surrounding the incident, such as when it occurred, when it was reported, when the status last changed, and so on. But this integration is hardly a one-way street. As team members swarm to solve the hot issue, every action they're taking in Jira software and Confluence is automatically piped directly into a dedicated HipChat room. This means everyone has up-to-the-second context, and the entire team has a single place to work in real time as they fix the issue. And to be 100% sure no one misses a beat, HipChat will automatically pull anyone who interacts with the Jira ticket into the HipChat room. So here's a screenshot of the SRE team's hot incident Confluence template, which has been fully customized to map to Atlassian best practices. Throughout the incident, the team uses this space to capture what they've tried and learned as they work to resolve the issue. Whether they're documenting the results from an impact analysis, exploring root causes, or just searching for the full context around a previous decision that was made, it's all here in this template. It's captured in one place. And as you might imagine, with so much context around the team's flow documented on one page, the PIR process becomes way more effective. But there's one more very important step in this incident response process that the SRE team has built right into their workflow. And that's the creation of a status page incident directly from the hot ticket. Maintaining open channels of communication with your customers is so vital in a severe incident. To do this, our SRE team relies on status page. So once someone from the SRE team is ready to make a public-facing update about an incident, they can do so in a matter of seconds directly from the hot ticket. And in the same pattern as the rest of the tools I've discussed today, once the status page incident has been created, a URL of that exact incident is printed back on the Jira ticket. Yet again, we see the power of having all comms channels in a single place and a click away for everyone. But having tools and process in place for our day-to-day work and our incident response process, it's not just convenient because it allows us to heavily dogfood our own products or build empathy with users. It does both of these things. But it's exactly the opposite. With all comms and data flowing through a single system, Jira, we have the perfect way to truly understand and know the flow of work throughout our teams and across our organization. Which brings me to our third guardrail, maintain one source of truth. While we do use many tools, both Atlassian tools and other tools, to get work done, we're firm believers in having one tool and system through which all data flows. As you saw in our last example, Jira integrates with just about everything under the sun, which makes it an ideal solution for knowing the flow across the various teams in your organization. This includes dev, ops, and many other teams. As most of you in this room know, it takes more than just a dev team to get working software into the hands of end users. And with Jira, every team can customize projects, workflows, and boards to suit their specific needs. But because all this work is being tracked in a single source of truth, When the need arises to consolidate everything into a single view, it's easy to do. Internally, we compile these consolidated views into what we call cross-project boards. Here's how it works. First, we line up every team's unique workflow side by side. Once this is complete, it's pretty common to see that not every workflow is the same. That's exactly how Jira is designed. For example, the marketing team needs to know when a feature is dark, but that's not necessarily something the design team's workflow takes into account. So to create one master view, we then map all statuses into one of 4 categories: to do, in progress, ready, and shipped. So in the case of dark features, that step gets mapped into the ready column. And this is what the cross-project board looks like once we have everything successfully mapped. As you can see, it's yet one more way in which we can truly know the flow of work and share it across the entire organization. Anyone can access this board. But this single source of truth goes beyond just having a board that's kept up to date and visible. It also sets the stage for an important cross-team ritual we call Boardwalk. Now, Boardwalk is an interactive weekly session that includes a much wider team, including members of our dev and ops teams. During Boardwalk, each team lead actively walks the entire group through everything that's happening on their team right on the board. Each team lead uses the cross-project board to do their Boardwalk, which reinforces the importance of every team keeping all this work up to date and in a single place. This practice gives the entire organization a simple, shared way to know the flow of work across multiple teams. And while our weekly Boardwalk is the perfect in-person ritual to keep multiple teams on the same page, it's worth mentioning that our teams also have automated much of this status reporting as possible. In part, we can trust the cross-project boards to be a single source of truth because they're tied directly into our developer tools. Because all engineering teams have automated the transition of Jira tickets based on the status of their code, every team using the cross-project board can be confident that the information they're seeing is always up to date and correct. Before we move on, let me quickly show you how this integration and automation works. Atlassian is a firm believer in feature branching. And one way this practice is made easier is through the create branch link that's on every Jira ticket. Because Jira and Bitbucket are tightly integrated, an engineer ready to kick off development work can do so directly from the ticket. But the real power of this integration only begins there. As the engineer continues to commit and build, the exact status of that work is continuously piped back onto the Jira ticket. Builds, pull requests, commits, they're all there in real time in one place. In other words, knowing the flow of work at any time is as simple as looking back at the Jira ticket on which that work was started. So as you've just seen, thanks to Jira's incredible flexibility and deep integration with other tools, it's the perfect and powerful source of truth for Atlassian as we strive to better understand and know our flow of work. Now, as the saying goes, knowing is half the battle. But when it comes to building a system for better, faster DevOps, we think knowing is actually just the first third. Now that you've seen firsthand the power and importance of staying laser focused on cycle time, dogfooding your own tools, and maintaining one source of truth, let's transition from how we know and understand our flow of work to how we control it. To take you through the second section, controlling the flow, I'm going to turn it over to Stephen. Stephen.
Thank you, Jake. All right. So as Jake implied, we use branches for everything, for all changes, for all kinds of work at Atlassian. So all development work is done on independent, short-lived branches. So short-lived branches, we'll talk about what a branch is, but short-lived in this case means days or hopefully hours. So this keeps unstable changes isolated from the master branch. We'll touch on that a bit more too. But it also triggers a number of workflow and integrations that allow our developers, and as we start getting real work done, it allows our systems, to see that work is going on and react to it and propagate that outwards. So it's isolated, we're able to track it, and once that code is finished, we can review it, make sure all the tests are passing, get it merged into master. So let's take a bit, I talked a bit about that too quickly, let's take a moment how that really looks. So as we saw earlier, We've added features to Jira to help practitioners, like developers, these can be designers even, broadcast signals about their work. And to get started with this, to kind of tie together the systems that they're using today and Jira, we take advantage of something from Jira, a feature called Advanced Workflow Triggers. So that starts with your Jira admin introducing, for example, your source code control tool to Jira. Once that happens, Jira sets up scheduled synchronizers or webhook synchronizers to watch the work that's going on in that other tool and derive status from that tool. So first we create that integration, or we configure the integration between those tools. Once that's in place, your developer, your practitioner, whoever he might be, can use either Jira to begin taking on a piece of work. So for example, I can stay within my favorite source code management tool, like maybe SourceTree, or maybe I'm a Git command line guy, and I can create a branch, and as long as I mention the Jira ticket properly, that's the Jira 30 bit in that feature slash line, Jira will detect that you've begun working on something it's tracking. So as commits continue, so it'll detect that you've begun working, and then it will transition that Jira ticket automatically from something that is open or pending, or in the backlog, into in progress, right? So the practitioner didn't have to go to Jira to do that, or if they did, they had the advantage of being able to hit the create branch button, that will then take them to the place where they want to get their work done. And they don't really have to spend time in Jira after that. So with that branch created, they begin an in progress ticket as they start committing. All of that activity is seen by Jira, and so not only are folks able to see that you've committed recently, but they can see that a particular work item might be stale because it hasn't been committed to recently. So that's very powerful. As that work is getting close to being finished, that practitioner will typically start a process called a pull request. And the pull request signals that the person is ready to integrate their work back into that master code line. And we have some processes that surround that ceremony, which we're going to talk more about with another guardrail. But this pull review process is central to the idea of not only having isolated work and bringing it back, but also having a moment to allow everyone to look at that work, collaborate on it, and kind of get smarter about that work and how it might get tackled in the future. So we have to learn through that process. Finally, when that pull request is resolved, as usually merged, as in we took that stream of work and we've brought it back into the main line, Jira will see that, and it can transition the ticket to done at that point automatically. So again, we have a complete life cycle of the Jira work item being taken care of without the practitioner necessarily having to spend time in Jira. Jira remains that one source of truth, but it isn't slowing folks down, and they're not having to context switch necessarily. This is a big pattern that we like to repeat in a lot of other places, and that's something I can spend some time talking with you about maybe later, but do find me. So for what it's worth, we have these Jira workflows. I mentioned a very simple one, but it's the case that as the automation works, it's going to see the movement, it's going to see these tickets taking on these various steps in the source code management release cadence or commit cadence, and then eventually tie those back to Jira. It's the case that we have more than just source code management triggers. So it's possible for static code analyzers, third-party tools with regarding to test management or even security audits to all get involved in participating with these triggers. You can learn a lot more about that at our Atlassian marketplace. There are thousands of add-ins and plugins that do things like integrate test managers into this Jira workflow so that the folks who are doing that work, running those test plans as their manual, for example, they can do that work where they like to do that work, and then the signals are being broadcasted back to Jira so that everyone can do the boardwalk, for example, and see what the status of the overall effort is. So let's take a look at a few more of these guardrails. Another critical practice that we rely on to control the flow of work is to treat configuration as code. Okay, the big idea here is that we want to control the flow of configuration and environment changes as effectively as we do source code changes, right? So this means taking steps to express the configuration, our pipelines, our flows, in probably text files and putting them under version control. This is an example of something that is showing us a workflow for how we transform our code into something we can deploy ultimately. So we can see, for example, it's defining something called a pipeline, more on that in a second, and it has a number of steps. We can see that when this particular thing needs to go do its work, it wants to be in the context of a particular image. That's a Docker container for those of you who know about that kind of thing. So this is a very concise way to see what a workflow is and how it's defined. I don't have to ask people questions about whether or not we're doing unit testing in our flow. I can see it right here, right? That is not the only kind of thing that you're going to want to capture. There are also environmental configurations that are important to keep track of. And so using something like HashiCorp's Terraform, we are capturing how resources and runtime environments are defined. In this case, it's a very simple example. We have two resources, AWS resources, in fact, and how they connect together. The big win is kind of played out here. Because these are text files, it's very easy to put them into a centralized repository, so everyone knows where to go to find out what the flow is. They know where to go to find out what the configuration of an environment is. It's a repository, so we can version control the things that are there. We can say that at a particular point in time when a bug came around that we're working on maybe a few weeks later, the configuration was thus. Now it is different. And so if we need to kind of hop back into that previous configuration so we can figure out why a bug may have been triggered, we can do that. Finally, this is very scalable. It's not only scalable because it's written down and it's repeatable. It's scalable because as you start to embrace these ideas, and we'll show a bit more of this too, I can take those workflow steps, for example. I can take those configuration steps, for example, and I can bring them to life on my laptop. Right? I don't necessarily have to bring all this stuff to life in a production environment so I can test it. With all of the power that we have with containers and the HashiCorp stuff, I can actually take advantage of these rich configurations of environments and these rich workflows in my development environment and start shifting to the left security audits, start shifting to the left problems surrounding parallel environments or complicated microservice environments. It's very scalable in that way. So these things that I just described, this branching idea, treating configuration as code, start to lead to the desire to automate everything. And so there are two guardrails that really kind of build on each other from a DevOps and a kind of a flow standpoint and controlling how we move work through our system effectively that I want to focus on. And so the first one is these steps, these actions that occur as we bring our work to life ought to be captured and automated as much as possible. In this case, I have shown you a few things. So we have, not only am I doing things like building my code with one of these shell scripts. So these are, if you know what a shell script is, let me know. I'll explain it to you. But we have ideas here like how we're going to build our application, how we run our application locally, how we do a static code analysis. We can do the OAuth security audits. We're also doing some interesting things here with regard to packaging and deployment. So there are specific steps for creating containerized versions of the application of the microservice that is being developed here. Also, we have the idea that we might be zipping it up outside of container and then publishing that up to an S3 bucket. All of those various little discrete things are right here. They're on my laptop as well as in what we deploy. And so this lets me as a software developer actually diagnose why these actions are running or not, or take the step to put a test version of a microservice into the S3 bucket so they can be reached by some other systems. It's having it one place where everyone can find it is super critical. And those things together lead to what is really probably the most important aspect of this, the kind of the technical control, the flow guardrails that I'm presenting today, and that is this thing, building every push. And so the idea here is that thanks to an elastic build framework, so we have the idea of having clouds that are capable of spinning up new resources wherein I can go ahead and run those security audits very aggressively, perform tests. With all of the automation, I'm in a situation where I can finally do that. But how do you orchestrate that? How do you bring that to life? How do you control that in a way that's consistent and repeatable? So we have a few examples of how that can happen. So one of them, for this crowd, there is this thing out there called AWS CodeStar. There's the idea of how you bind together their code deploy, the code pipeline capabilities, code build, and even Jira to do things like track what's being worked on and what is in what's being built right now, what is in which environment. All of those concerns are something you can address using CodeStar. And that's great for the Atlassian crowd if you're around. Happens to be the case that we're Atlassian. And at Atlassian, we rely very heavily on our own tools, as Jake mentioned. So we're big Bitbucket users, of course. And we take advantage of our own in-house Elastic build fabric that's called Bitbucket Pipelines. It's a relatively new feature, maybe you haven't run across it yet. So Bitbucket Pipelines is our new cloud-based Elastic continuous integration, continuous development solution built directly into Bitbucket. So at a glance, you can see a few things here. There's where the pipelines feature is to be found. And we can see at a glance what the build status is of every single commit, every single pull request. We can see who's been involved. And this is kind of my favorite feature about it is Bitbucket not only sees those commits and those pull requests, it's not only running your builds in this elastic on-demand framework that automatically spins up new build agents and then collapses them when they're done, but it's collecting each of the steps of the pipeline output for creating and bringing code to life and making that visible right there in the user interface. If something goes wrong, I get notified right away with a URL that takes me immediately to the step that failed. It's a very rich user interface too. This is getting better and better. Like for example, a lot of the items that are mentioned sometimes in the stack traces are becoming clickable. So if there was a mistake in some Java file that I tried to deploy, I can be taken to it right away. Or if there's a mistake in the configuration that defines the pipeline, I can be taken directly to that file and make a change without kind of missing a beat. It's very addicting when you get used to it. It is called Bitbucket Pipelines, so it may be the case that you have different flows or different pipelines, different actions that need to be taken, depending upon whether you're merging in a change that is feature work that you're up to, or perhaps you want to merge a change into a controlled environment using release as environments as branches patterns, where you might do something like a heavyweight performance test, for example. So to define those capabilities, or to define those steps independently, we had the idea of multiple pipelines. So there's your feature work pipeline where we just build and test, but if we're merging something into master, we do build and test, but we also take an additional step. We perform a deployment in this picture. And that kind of takes us to something that's coming along, which is, first off, not everybody wants to deploy automatically every time a pipeline runs. So we do have manual features, manual step capabilities, those deploy to staging and deploy to production steps, they would not run automatically. Someone has to go in there and click the button if that's desired. Bitbucket Pipelines is this desire to cause pipelines to go into a deployment end state has become very popular internally, and so we've brought about externally a cool new feature called Bitbucket Deployments. So now we're not only tracking all of those commits, how they build, what their status is, taking you to problems as they occur, but we're also tracking how they move into deployed environments, and this is just getting richer and richer. We're building this into more external tools as well, so that you'll be able to track all of the things that make up a particular release. So we've got all this automation, we've got all of this configuration as code, we've got the ability to kind of isolate work so that we can test it very quickly and succinctly. This leads to this idea that our developers are moving as quickly as we can get them to move. We're getting everyone throughout that flow. The idea is to get that flow moving quickly. But we still need to make sure that what we're doing is controlled and that the output is as it should be. So trust but enforce comes into our 8th guardrail. And this is the idea of taking advantage of the PR process and the branching. So for the folks who haven't heard of this before, again, the pull request is the point in the development life cycle of a feature where we've been performing that work, we've been doing our work on a separate branch, and we now want to combine it back into the master branch that everyone will ultimately integrate against. That act of merging things in is the pull request. Someone is asking for that merge to occur. Other folks, other team members, for example, would get involved in reviewing that code. And so we'd see probably, if I had any issues with the code I was trying to pull in, my teammates would work with me, additional builds would occur, and we'd ultimately get approval. We can specify with branch permissions that we demand at least 2 folks sign off on the work that I do, and that all of the things that I've been up to have to build cleanly. This is something that the build pipeline can take care of. It's something that our Elastic build framework can do for every single pull request. We don't have to just wait for some of those pull requests because our build apparatus is too constrained. That's just gone away. All right, so here's what the pull request looks like from the engineer's perspective. The author assigns a number of reviewers, specific people to review it. The reviewers get to see what the status of the build or the most recent builds has been. If they sign off on everything, or I'm sorry, one more thing here, which is nice, is the inline commenting. So as the reviewers are going about looking at the change, they can see exactly what's changed, but then they can also kind of comment exactly on issues that need adjustment. The power of this, by the way, is not just that we're gating what is getting merged. We're not just making sure that what gets merged is the best thing. It's causing our developers to work together and collaborate. They're staring at these problems together and they're learning how each other are working. And this is one of the most fundamental underpinnings of DevOps that we're trying to stay true to and that I'd like you guys to consider, which is that it's a collaborative problem. The automation can accelerate how these things work, but ultimately the people still have to get together and learn from each other. And so it's through a PR process, and it's through inline comments, and it's through being taken to a problem and having people surround that problem together that we learn how to truly make sure that we're not just deploying great code, but that it's the code that we need. So by placing code, configuration, and context under version control, we're not only tracking those changes, we're also controlling how our systems and configurations evolve. We can see how those versions have changed over time. We can go back to them. And we're doing that with the practices and the tools. This is important. We're doing that with the practices and tools that our developers and our practitioners are already familiar with. We're not forcing them to pick up new ideas. We're not forcing them to change the tools that they want to use. We're fitting right there into their daily life. And we're pulling signals like those triggers from the work that they're doing and promoting that up into the source of truth so that everyone can see what's going on without getting distracted by having to make reports about that or report that progress. Yeah, but it is until our work sees the light of day that we can truly measure the impact of the work that we're bringing to life. So now that we've taken a closer look at the ways in which we know and control the flow of work, it's time to dive into the third and final section of our talk, improving the flow. So equally important to knowing and controlling the flow and understanding how things move through that system is how we can improve it, how we can embrace what we know and apply that to the flow, increase the flow, and improve the flow, improve the way we develop and deliver that software. I'm going to hand it back to Jake. Thanks, Guy.
Thanks, Stephen. All right, so up to this point in the presentation, we've talked a lot about shipping value to end users. However, we've yet to show you where and how we actually do this. So let's use the third section to dive into that.
Yeah.
The truth is that none of us, no one in this room, can be sure about the value of work until it's actually in the hands of customers. Putting new features and improvements in front of users as early and as often as possible has become a fundamental guardrail for our company. This means deploying and testing work into production, or as we like to say, prod is truth. Now, testing in production might sound a little crazy, but there are tools out there that make it safe. I'm going to give you one example now. To perform cautious rollouts of new features to live users in a production system, we rely pretty heavily on a tool called Launch Darkly. Launch Darkly allows us to perform progressive rollouts using a technique known as feature flagging. While we've adopted the process of feature flagging for a variety of reasons, a few of the biggest benefits are custom percentage rollouts and detailed targeting rules, clear A/B testing between multiple experiences, and real-time analytics. A perfect example of this feature flagging technique in action was the recent rollout of our new global sidebar in Jira Software Cloud. For this release, we set up a feature flag to enable a progressive rollout to our users. To begin, we chose a small set of early access accounts to start seeing the new navigation experience. Then we began carefully measuring how these users responded to the new nav, while simultaneously parsing through the thousands of pieces of feedback that began pouring in about the experience. After several weeks of testing and measuring, our design and engineering teams, they then made a series of improvements based on the feedback they'd received and the usage patterns we were monitoring. So once this feedback had been integrated, we began rolling out the V2 of the new navigation to a slightly larger fixed percentage of our users. Over the next several months, we repeated this same measurement and feedback process many, many times before eventually all users were seeing and using a great new navigation experience. And because we tested it in production every step of the way, we knew that the final rollout to all customers was going to be something they would like. Of course, a huge added benefit of this progressive rollout strategy is that at any point, as we're ramping it up, if there was a major bug or issue, we could easily ramp it back down or even turn the experience off. LaunchDarkly makes this very easy. Now, some of you might be wondering, if we chose to roll out a feature progressively, how do you know when it's been a success? When do you roll it out versus knowing when to pull it back? It's a great question. One of the things we love most about LaunchDarkly is its ability to let us split test different experiences. So when we're rolling out a change, we implement multiple variations of a specific feature set and deploy them to different user cohorts. For example, cohort A might continue to see the original navigation experience, or cohort B might see the brand new experience. Once we can compare apples to apples, our PM team then carefully watches and measures the differences of behavior across the two cohorts and ultimately decides, based on the data, which experience is a winner. In short, we let the data tell us which version is improving the flow of value to our users. Now, if you haven't picked up on this already, we're pretty big fans of continuous feedback and improvement. It's hard, real data that makes this possible. In fact, without hard, real data, it would be impossible to see and measure if or how our work is truly impacting end users and improving the flow. Which brings us to our 10th and final guardrail. Shipping is just the beginning. At Atlassian, we measure absolutely everything. For example, every action in any of our products translates to an anonymous analytic event that we use to make decisions on how to improve the user experience over time. We want to prove that everything we ship, it moves the needle in a positive way and improves the lives of our users. If it doesn't, we're doing something wrong. Now, there are times when the data comes back and it doesn't, and it can be pretty brutal. But what this means is that it's just a chance for us to continually iterate until we get it right. But it's naive to think that analytics alone are going to tell us the entire story. In fact, many times it's our users that tell us, in their own words, what they like and don't like, or how they want the product to be built. Now, one of Atlassian's key values is don't F the customer. If you don't believe me, Google it. See for yourself. So you better believe that with this mindset, we carefully monitor any and all customer feedback that comes in, and we're always asking for more of it. If you have a question or concern about anything in our products, we want to know about it. And with Jira Service Desk, we provide all of our users with a customizable portal that allows them to comfortably raise their concerns as a ticket directly in our system. Internally, Jira Service Desk provides our support teams with an agent view, queues, SLAs, and even a knowledge base integration. But all external requests and improvement requests immediately become work items in our backlog. They're in our system. They can then be triaged. This level of traceability gives our customers the ability to track their requests through our system. Yes, you heard that correctly. End-to-end traceability between what our customers are asking for and what our teams are working on. And communication is a two-way street. As we expect our users to communicate with us, we know it's equally important that we need to be continually communicating with them. So when we ship something that we think may have a negative impact on our systems, or our systems tell us is having a negative impact on our systems, we're the first to let users know about it. To communicate with customers during downtime, our teams rely on status page. And I mentioned this earlier when I was talking about our SRE teams. Status page is the #1 status and communication tool for SaaS companies. It's the perfect channel to communicate with your customers when an incident might be affecting their service. So at Atlassian, we strive to push the boundaries around how we ship great software. It's built on our constant desire to improve the flow of work. We've touched on a couple ideas here, including feature flagging, a deep commitment to gathering user feedback, communicating with users even during downtime. Using techniques like this, we're not only strengthening the products we deliver, but we're actually strengthening the way we deliver products. We're continuously improving the flow. So now that we've taken you through how we think about knowing, controlling, and improving the flow of work, I'm going to turn it back over to Stephen to bring us home.
Thanks, Jim. All right, okay, so we've really just scratched the surface on many, many different practices or guardrails that we use at Atlassian to get work done. There's a lot to think about here, but if I could encourage you to take away only 3 things, I'd ask you to focus on the flow stuff, right? So later today, take a moment to consider how you might know the flow of your own work. That is, does everyone understand what the team's mission is? Do they understand what each member of the team is doing to contribute to that mission? And you know where to look to find out how they're doing against that mission. So this is, again, the way I like to think about know the flow is kind of like having a map. I want to understand what is the city I live in? What are all the people doing who live there? What are all their expertise? What are their expertise? How are they impacting what we do? Where would I go to get something done? Why would they come to me? Having that picture of where everyone's at and how to get to them is that first, know the flow. And the things we do, even with dog fooding, teaches us how to figure that out internally. The next thing that we worry about is controlling the flow, right? So ask yourself, if I understand how I interact with the rest of the team members, am I taking advantage of how we interact most effectively? Can I use version control techniques like the branching? Can I use automation to make sure that as that work moves around the people that I can see, that moves around that flow that we can see, that it's happening as effectively as possible? What can we do to take advantage of that flow and make it work in a healthy, predictable, sustainable way? And finally, there's the idea of improving the flow. If I can see everything, if I can watch things move around, if I can get signals as work moves around that system, we can begin to think about how we would improve the system so that there are less handoffs. Or maybe as things are bunching up in a particular corner of our flow, we can devise ways around that. We can mitigate bottlenecks and constraints. So I'd invite you to think about how you can improve the flow as well. These practices don't replace your existing tools, but they should leverage them. DevOps is built on the principles of communication, collaboration, and integration. The Atlassian platform is the fabric that weaves the DevOps tool stack together. In addition to providing tools that improve teamwork, Atlassian also offers a marketplace of over 3,000 add-ons, plugins, integrations to let each team member work in the systems that they're used to, work with the tools that they're used to, but still contribute status information, automate the collection of status collection up into that single source of truth. All right, in closing, let me point you to 2 resources, okay? If you are using or thinking about using AWS CodeStar, you should definitely look into our exclusive 5-user free tier Jira software license offer. This offer is available exclusively with AWS, and the only way you can sign up for your free license is through the extensions tab of the CodeStar dashboard, that little admin panel thing down there. Right? I believe there are about 500 of these free licenses left, so if you want one, you may want to move fast. Finally, Atlassian has been accumulating a bunch of stories, both stuff that happens internally and the people we talk to, and posting that information about how they've performed their DevOps journey at atlassian.com/DevOps. So you can go there. In particular, there's an ebook. There's a DevOps ebook that has a wonderful set of stories. My favorite one is the SRE story that talks about how we embrace DevOps and some other ideas to truly transformed the way we tackle certain kinds of problems. It's a very interesting story. All right, so again, that was just the tip of the iceberg of 10 DevOps practices that we've covered so far. Let me take a moment. I know I speak for Jake and myself. Thank you so much for spending time with us over the past 50 minutes. We are more than willing to spend time with you. We'll be downstairs at the expo hall. Atlassian has a booth as you enter the expo hall. It's sort of off to the left. We'd love to, obviously, engage you on these issues or find out how you're doing with your DevOps journey and what we can do to kind of think about making that better for you. All right. By the way, we're here for another 8 minutes, so if you do have questions, please feel free to approach us.